Okay, so this is a first example lecture for module number 3. This is just plain old resistor simplification. So what I'd like you to do is to copy the problem down and try to work it yourself without watching the video and see how far you can get. Hopefully you'll get all the way through. So I'd like you to try that if you would. So I'm going to pretend that I'm pausing for a minute so you can do that. So what we're trying to accomplish with this problem is find the equivalent resistance relative to these 2 points here and here. So if you imagine for a second, I'm not going to leave this in, I'm going to erase it, but you'll be able to see it in the video, is if we had a multimeter and we had 2 probes on the multimeter, we would attach one probe here and the other probe here to measure that resistance. So we're basically taking a measurement relative to those 2 points. So what's important to note about that is that we can't do anything to lose those 2 points. So these 2 points are nodes in the circuit, and they are nodes. We don't want to lose these. So I'm going to kind of emphasize them here in green. We don't want to do anything to lose those 2 points until we get simplified all the way down to a single resistor. Okay, so what we would do, very much like the just resistor simplification and expansion that we did in the module, in the lecture module, is we're going to identify our nodes, and I'm going to identify them by highlighting them again. So we're going to have a node here where those 3 elements come together. We're going to have a node here where those 2 elements come together. We've got a node here where all of these things come together. We've got a node here where these 3 elements come together. We have a node here and then a node here. Okay, and so I'm going to label these nodes. I'm not going to label where we're taking the measurement, but I'm going to label all of the other nodes, and I'm going to do them in red so we can see them. So I'm going to call this node 1. I'm going to call this node 2. I'm going to call this node 3. I'm going to call this node 4. I'm going to call this one node 5, and I'm not sure why I jumped around when I worked this problem, but I did. And this one node 6. Okay, so let's see what we've got here. So let's start by looking at the spots where we have elements in series, and that's at node 5 and node 6. So if we look at node 6, we've got 3 in series with 5 to make an 8 ohm resistor. We will lose, and we're not solving for anything here other than the resistance, so we don't have to worry about keeping track of voltages and currents here. So we will lose node 6 here when we make this simplification. And at node 5, we have the same situation, but in this case we'll have 15 in parallel with 45. We will get 60 ohms there, and we will lose node 5 when we make that combination. So what I want to do is I want to start by dealing with the parts of the circuit that I didn't change. So I'm going to start here in the middle with node 3. So here's node 3, and I still have the, and I'm going to come down here and draw this part down. So I still have the 6 ohm resistor up here. So 6 ohm resistor is still there. Down here, this is node 2, and this is node 1 here, and it helps sometimes to draw the nodes. Between node 1 and node 2, I still have that 40 ohm resistor. This is still 1.5 ohms. Then down here at node 2 to node 4, I still have that 5.2 ohm resistor. And then I also have that 12 ohm resistor from node 3 to node 4. Okay, so we've got everything that we had beforehand. Now we're going to add in the equivalent resistance. So at node 6, we had 3 plus 5, so we're going to lose node 6, but we'll still have the 5 ohm resistor, the equivalent 5 ohm resistor, connected between node 3 and node 4. So this is 5 ohms here. Again, we've lost node 6. And the same thing here between node 1 and node 2. Use the highlighter. Between node 1 and node 2, we're going to have the 60 ohm series combination, and we'll lose node 5. So now we've got 60 ohms there. This is still the equivalent resistance we're measuring from here to here. So we've lost node 5 and node 6. They're not on the circuit anymore. We have nodes 1, 2, 3, and 4 left. Okay, so now we're going to go to the next simplification. So now, if we look between node 1 and node 2, we've got, between node 1 and node 2, we have the 40 and the 60 in parallel. And between node 3 and node 4, we've got 12 in parallel with 5. And I'm sorry, that should be 8, shouldn't it? This should be 8. My apologies. This should be 8. 8. There we go. 8. So between node 3 and node 4, we have the 8 and the 12 ohm resistor in parallel. So let's go with that next. So at 1 and 2, we have 60 in parallel with 40, which is equal to 2400 divided by 100, or this is equal to 24 ohms. We're not going to lose any nodes when we make a parallel connection. And when we look at 3 and 4, it's connected there, we've got 12 in parallel with 8, so that is what is that, 96 over 20, and that's going to be 4.8 ohms when we do the math. Yeah. Okay, so now we will simplify again. And again, it makes sense to start with what we haven't done anything with. So I'm going to try to do that without losing, I don't want to lose that picture. So we've got between node 1 and node 3, we have the 6 ohm resistor. We haven't done anything with that. And here we have the 1.5 ohm resistor. We haven't done anything with that. Okay, and then we'll have node 2 here, and node 4. Between node 2 and node 4, we can see the bottom of that circuit. We've got that 5.2 ohm resistor that we haven't done anything to yet. Okay, so now let's make those parallel combinations and simplify the circuit. So we've got this 24 ohm resistor between node 1 and node 2. So I'm going to draw that here. And then between node 3 and node 4, we've got that 4.8 parallel combination, which I will draw in here. So 4.8 ohms, and this is 24 ohms. Okay, and this is still REQ, what we are solving for relative to those 2 points. So we will continue to do this. We made parallel combinations before. We will make series ones now. You typically do that. You make series and then parallel, series, then parallel. And so we've got some series ones to make here. So at node 1, we've got 6 in series with 24. At node 4, we have 4.8 in series with 5.2. So at node 1, we have 24 plus 6 is equal to 30 ohms. We're going to lose node 1 when we make that combination. And then at node 4, we've got 4.8 plus 5.2, which will be 10 ohms, and we will lose node 2. Okay, so let's see if we can draw this in down here. So I'm gonna lose node 1 and node 4. So I've really only got, I'm going to try to squeeze this in here. I've got the 1.5 ohm resistor. This is 3. This is 2. I'm squeezing it in there, I'm sorry. Between node 3 and node 2, we've got that 30 ohm resistor. Where we've lost node 1. And then between node 3 and node 2 on the other side, where we lose node 4, we've got the 10 ohm resistor. You know, I'm gonna put node 2 inside there. There we go. So here's 10 ohms. And here's our equivalent resistance relative to those 2 points. Okay. So now we've got things in parallel again. Okay. Between node 3 and node 2, we now have the 30 ohm resistor and the 10 ohm resistor in parallel. The 1.5 ohm resistor doesn't come into play yet. It's not in series or in parallel with anything. Okay. So at 3 and 2, we have 30 in parallel with 10. That's equal to 300 divided by 40, which is 7.5. So that's our equivalent resistance there. So now again, redrawing. Remember, we don't lose any nodes when we combine in parallel. So I've got node 3 and node 2. Here's that 1.5 ohm resistor. Here's REQ relative to those 2 points. Now, it doesn't matter which side of the nodes I draw that 7.5 ohm resistor. I'm going to draw it to the right, but it does not matter. I could have easily have drawn it to the left. Here's 7.5 ohms. Okay, and now at node 3, I've got the series connection of 1.5 and 7.5. They are not in parallel because they're not holding hands. They don't share the same 2 nodes. They only share this one. 7.5 is connected here. This one is connected to the open terminal. Okay, so at 3, we have 7.5 plus 1.5, or 9 ohms. And so now we have REQ relative to those 2 points, and this is 9 ohms. This is node, well, this is technically node 2, but it's really just a part of the terminal. Okay, so that is how you simplify. You just keep working down, making series and parallel connections as you go. Now, as you get more comfortable with this, you probably wouldn't have to go through every single step like this. I would have probably done, you know, just a couple of steps. So, but as you get more comfortable with it, you'll be able to see those a few steps ahead.